All right, we're doing 1695 maximum erasure value. You're given an array of positive integers, nums, and you want to erase a subarray containing unique elements. The score you get by erasing subarray is equal to the sum of its elements. Return a maximum score by erasing exactly one subarray. Okay, so 4, 2, 4, 5, 6. You removed 4 here. I want to erase a subarray containing unique element. Oh, I see. So they've erased actually this. This case, you would erase 5, 2, 1. You could erase 2, 5. I see. So you're looking for the longest array or the biggest array, like the biggest sum array that has unique elements, I think is what we're looking for here. And in subarray is, makes this really convoluted definition that like, blah, 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 blah. It's essentially saying that they're contiguous, they're next to each other. At the subarray, so 4, 2, 4, 2, anything that's like next to this is a subarray, but if there's a skip, so 2 and 5 not be a subarray. I bet you this is like 1696. I bet you this has like a two-parter, but okay. Let's do the solution. I'm thinking about using a sliding window here. Focusing on clarity message here. What's nice about this problem is I kind of see what the solution is going to be, so I can dictate it a little better. I watched some of my older videos and I was just rambling sometimes, which, it's not always the easiest to figure out these problems. But we're going to have a max res, which is going to equal to 0, and that's going to be the maximum return value that we'll ever have. And I'm also going to have the cur res, which will be the current kind of, I don't know, cur res, not exactly cur score. We'll make this more proper. Cur score, max score. And then we want to also keep track of the left, which is going to equal 0. And so for I in range of of n, we actually might be able to start this at, I think we have to start this at 0 actually. So let's put this, instead of I, we're going to do R, so that's L and R. And we're also going to need one more thing. We're going to need the set of unique values, which is going to equal a set, and that will keep track of what values we've already seen. And that the set is important because it allows us to access these values in all of one time. And it makes things way more efficient. So it's easy to check. Does 4 already exist? It would be really, really quick to check that rather than having to check the whole entire list every single time. It's an O of n versus O of 1 operation. So sets are definitely, we could use a list. List could work. It just will probably not pass the runtime. Yeah, it would be 10 to the 9th. So yeah. So what we're gonna do is if nums of r in unique values L is gonna equal R. Well, yeah, right? There's never a case where Like, that wouldn't be the case. You always want to restart, like, whenever you see a 424. You might want L to be 2. So we start with 4. Then we get 4-2. Then 4-2-4, which would fail. So we would increment. This is going to be a while. L plus equals 1. And so yeah, what we're doing here is so if we get the 4, so what happens here is we have to check while we still have a 4. So we get to this 4, and let's say we have 4-2. We would say, okay, L's got to be increased by 1. Now we're checking 2. And now the list does not contain a 4. But imagine we had like 3 and a 4. We would check the 3, 4. We would delete the 3, but we'd still have 2 4s in there. So we have to go another iteration. So this was L's catching up here. Well, L is less than R. And I think that you always want L to be less than R. Yeah. Could create some issues if you don't do that. And then unique values dot, is there remove? I don't even know. I don't remember dot remove, right? We'll find out. Nums of R, or nums of L rather. Well, we actually want to swip these because we're incrementing L, and then else we just want to do unique values dot add nums of R. So we're adding the value to the array. I think we don't even need that L greater less than or equal to R. We might not need this kind of whole check here because that would mean that the unique value is empty. But we'll just keep it for now. It's just an extra helper. Unique. So then we would add it to the list, and then we want to set max score equal to max of max score and first score. Okay. We haven't been working with cur score. Okay, let me just fix this a little bit. Cur score minus equals nums of L. Cur. Yeah, so we're just kind of incrementing, fixing cur score. And then here, this is a pretty nice and easy one, cur score. Like that. Let's see if we can get this first iteration too. Let's just check over our work. And max score, current score, unique values, set L equals 0. For each value in the range is R okay starting. No, that would fail that. Yeah, so they would skip over this because L is less than R to begin with. And unique values. Yeah, this is not needed. I'm pretty confident on that. Unique values. So we add the unique value to the set. Car score plus equals 1. Whatever. And then we just set max score equal to that. Yeah, I feel pretty confident. I'm going to send it. Oh my gosh. I spelled unique wrong. Almost perfect. Oh, we need to get some errors out. Okay. Obviously, the answer is 10,001. Why are we getting one? What? Unique values that add nums of r. So we're adding 0, which is 10,000. Wait, no. Nums of r is 1. Let me add 1 to the max score. Wait, I'm so confused here. Wait, what? Wait, we're missing something super trivial here, but let me just print current score. What? I feel like it should be 10,001. Yeah, wait, am I? Oh my gosh, I'm printing cur score. Resubmit. Yeah, okay. That's funny. That's funny. Yeah, so I put cur score. That should be max score, obviously. Okay, and that's it for today. Almost perfect. Messed up on two silly cases. Spelled that wrong. Not even count that one is wrong, but should have put curse max score here, not curse score. I guess I was getting sloppy at the end, but overall good. Nice solution. Let's see what other people did. Probably yes, landing window. Pretty simple. Yeah, I think that's it.